Hello, I'm Henrik Sjöstrand, or LixGBG, as I'm called on GitHub and Gitter and some other social media. So in this short movie, I'm going to introduce a new feature that I've been developing for Nightscout reports. And it's a feature to help analyze the behavior of closed-loop systems, primarily the Loop app, which we are using. So I call this feature the Loopalyzer, and you can find it on its own tab on the right of the Nightscout reports. So when you click this tab, you have the normal Nightscout report settings. And to show how it works, I can start by analyzing a single day. So let's pick a day that I know that I have some good reasonable data to show you. So I picked Tuesday this week, which was a normal school day for my kid. So I click Show, and it shows the Loopalyzer report. So this is a Loopalyzer report. It consists of 5 different graphs, which are all time aligned and stacked on top of each other. So the first one is the basal profile, shown in blue. The second one is the blood glucose response, and in light green you have the low and the high targets. The third one is the temp basal delta. So if this is above 0, it means that loop has increased basal. If it's below 0, it means that loop has cut basal. The fourth one is the IOB, or insulin on board. So this is the net resulting IOB, and it comes from both the bolus injections as well as loop's actions. The fifth and the last one is the carbs on board, shown in green. So with these charts, I can really see how loop is acting on carbs and EOB and the blood glucose. So this Tuesday, I can see that my son, he had approximately 45 grams of carbs for breakfast, this black line, at around 7 o'clock. He took his insulin shot, and loop started to act on it. So it low temped and high temped, and then it low temp for approximately 2.5 hours to avoid him going low. And I can see that the blood glucose started to rise a couple of minutes after he ate the breakfast, and it went from around 6 until 9. So it's a really good day, really good breakfast. And then it started to decline. Another interesting thing I can also see in this report is that the hours before breakfast, he had 0 carbs in his body. And he also had 0 IOB. And when you can find these occasions where you have both 0 carbs and 0 IOB, then you can look at your blood glucose. And if your basal profile is correct, then the glucose response should be really flat or close to flat. So it's fairly okay basal profile for me here. I can also go back in time by using the backward button here, and forward in time by using forward. So if I go back and look at Monday, the 7th this week, I have a similar graph. I see that he had breakfast at 7:30. He had some snack at around 9. He took some insulin, loop high temp, blood glucose went high, loop low temp, etc. So I can use these kind of charts to go back and forth and see how loop has reacted on these different situations. But usually you want to see the average over a couple of days. So if I select average between Monday, Tuesday, Wednesday this week, so from 7th to 9th, and I click show, I see the average of these 3 days. So here I can see that my son had breakfast at around 7 one day, 7:10 one day, and then 7:30 one day. Excuse me. But the problem is when you show the average over a couple of days, all the graphs are really smeared out in time. So you can, for example, see the IUB. It's kind of like adding up and then adding up even more. And you can see the blood glucose response. It looks like it goes from 5 to approximately 9 in even more than an hour. So it looks like it's really slow rise of blood glucose. So this doesn't really give the whole picture. So I've also added a feature that I call time shift. And time shift allows you to align all of these meals so it looks like you had them on one single point in time. And then it adjusts all of the other values for all of the other charts, so it appears that you had these breakfasts or the other meals at one single point in time. So if I go up and I select yes, do the time shift, and I want to find all meals want to find the first meal for each day, which is above a certain amount of carbs, for example 10 carbs. And then I click show. What you then see is that Loopalyzer has then time shifted all meals, so it looks like they are all happening at the same time, so approximately 7:15 here. It also has time shifted the insulin on board and aligned them, so it looks like it took all the insulin at the same time, and we can see how the insulin decays, and we can see how the average loop has reacted on the blood glucose response. So it has low temp and high temp, and then done some low temping for approximately 2.5 hours to avoid him going low. And you can also see that the blood glucose is really growing from approximately 6 until 9 in even less than half an hour, approximately 20 minutes. So it did not take a full hour to go from like 5, 6 to 9 millimole. It only took maybe some 20 minutes to do the rise. So this actually gives you a much better view. You can average over a number of days, and you can still have them time aligned on certain spots. And of course, if you do the time align, you should not really, if you time align on breakfast, you should really not pay much attention to the data that are happening later in the evening, for example. So time align or time shift actually is more relevant from the starting point than just a few hours, maybe for the full duration of the insulin action. So this report is very useful to me, and I hope some more people can use it. So pay it forward. Thanks. Bye.